Okay, accelerated math, 45, 45, 90 triangles. If Barney were talking about this, he would say these are special. Special. Everyone is special in his or her own way. He would say it something like that, but he would sing it nice. I am not going to sing it. We're looking at special right triangles. 45, 45, 90 is special, and it has a nice, nice little rule here that looks like this. You've 1, 1, square root of 2. You might be saying, well, what are you talking about? Okay, the legs, which are the sides that are adjacent to the right angle, that are basically next to the right angle, those are 1 and 1. And then the hypotenuse, the one that is across from the right angle, is on the square root of 2. Let me give you another example here, because you might be going, okay, if this is 10 and this is 10, then the hypotenuse is 10 on the square root of 2. Easy, easy. We're just taking the legs or the short sides and multiplying by the square root of 2. If you've got to go the other way, then you're just going to divide by the square root of 2. So if this is 20, then the leg is going to be 20 divided by the square root of 2. Okay, and then I'm going to show you how we're going to have to work with that square root of 2 and get it out of the denominator. Alright, so let's take a look at what we have on this problem. So here's the 45, so this is a leg, and this is a leg, and they want to know the hypotenuse. Ooh, this is a nice easy one, 6 on the square root of 2. That's it. You thought this was difficult. Next one. Well, let's look. Let me go down to this one down here. Here's a leg. They want to know the hypotenuse, so all you're doing is saying 7 times the square root of 2, and that's it. Alright, this one a little bit different. I'm going from the hypotenuse back down to a leg, actually this leg, and in a 45, 45, see this is 45 also, the legs are both the same. So they want to know this leg over here, which would be the same as this one over here, but since we're going from hypotenuse to leg, instead of multiplying by the square root of 2, we're going to do the opposite. We're working backwards. We're going to divide by the square root of 2. Now the problem is they don't like that square root of 2 in the denominator, so we need to multiply that by the square root of 2 and also the numerator by the square root of 2. I want you to think back quickly to 5th grade, 3rd grade, something like that. They were talking about trying to, like if I was going to do 2/3 plus 1/4, and I needed to get a common denominator, and my common denominator is obviously 12, so I need to convert 2/3 into 12. I multiply this by 4 and this by 4. That was called, some call it, math teachers call that the big 1 concept. 4 over 4 is just 1, so I made it kind of look like a 1 there. It's not changing the value of this, it's just changing the way it looks. 8/12 is the same thing as 2/3, but now I have a common denominator. So we're doing the same thing here. We're using the big 1, or multiplying this thing by 1 to get rid of that denominator with the square root in it. Square root of 2 times square root of 2 down the denominator is the square root of 4, and we know that the square root of 4 is 2. On top, you end up with 4 on the square root of 2. That's our answer. Mathematicians don't mind the square root being up in the numerator, but they don't like it in the denominator. Alright, now, I thought for just a second there that maybe I didn't even have the right answer because that one's not listed there. But what can I do with this 4 and this 2? Well, I can reduce them. 4 divided by 2, or 2 goes into this once, 2 goes into this twice. So it's kind of like 2 on the square root of 2 over 1. When something's over 1, you can just eliminate that 1. 2 on the square root of 2. Woohoo! Alright. Here we are, going hypotenuse back again. So it's 7 divided by square root of 2. We're going to use that big 1 concept, or multiplying that, rationalizing that denominator, getting that square root out of there. We get square root of 4 down below, 7 on the square root of 2 up above. The square root of 4 simplifies to 2, and we got 7 on the square root of 2 still in the numerator. There it is. Notice that these could not be reduced, so we just leave it that way. Alrighty, and finally they give us more of a kind of a word problem kind of thing, where they get telling us the triangle ABC, where angle A is the right angle. So just make sure you read it and draw it accordingly. Angle B is 45 degrees. I did not draw this to scale very well. If that's 45, then this is also 45. This is angle B. This is angle C then. They said if AB is 32, then find AC. And so this is the other leg. Oh boy, that was a tough one. That one's got to be 32. The legs are both going to be the same. Alright, they're trying to trick you on that one. Alright, and last thing I want to show is I want to go back to this one where we got this answer, and I just want to show you with a calculator that 7 divided by the square root of 2, if you did it with a calculator, 7, throw it into a fraction, square root 2. I'm going to show you that the calculator is doing exactly what we did. 7 on the square root of 2 divided by 2. Alright, have fun with it.